Hey folks, welcome back. Doc D in the Dungeon, and today we are starting on our slow speed grinder project. What is a slow speed grinder? A slow speed grinder, well, there are different models, there are different makes, and they are made for different things. So specifically what I'm talking about is a grinder for grinding carbide tooling. And in particular, I just completed Keith Rucker's machinery scraping class, and so this is a Sandvik style scraper, and so this is just a large carbide insert, right? Well, we also have DAPRA style, which can be used both manually and also on a power scraper, and I just got these in from Hudson Machine, I think it's Hudson Machine Repair, and they're a little pricey, but if you watch my reflections on scraping class from Keith Rucker's scraping class, I started out using this and it worked, but my skill level, as a novice wasn't good enough to control it the way that I needed to. And so, ultimately Keith let me borrow his DAPRA style. Hi Callie, yeah. Callie had to come in and say hi. And so, yeah, anyhow, I wound up, I like these better, and so I ordered one when I got home. They're a little pricey, a little spendy, but I think it's going to be well worth it. So anyhow, even though these are carbide tipped and these are just brazed on carbide, Callie, goodness gracious, Cat wants nothing to do with me until I'm on camera, then she wants to be over here. They need sharpening periodically, and over the course of the 3-day class at Keith Rucker's, I bet I sharpened a dozen times or more. And you just, Callie, get away from me, crazy cat. So when I took Keith's class, it came with an 18-inch straight edge. I had purchased a 9-inch straight edge for the purposes of scraping in, and I had a surface plate that was just big enough to do this. I used it for my Tormach TTS tooling setup. So I want to scrape this in. So that'll be another class. That'll be another video series, probably just one video in the near future. But in the interim, I just got these in. Was it yesterday? Yesterday, and so I need to be able to sharpen those. And also I have a lot of carbide insert tooling. You can sharpen carbide insert tooling on those as well. So anyhow, this style of slow speed carbide grinder is set to run somewhere around 300 RPM. Which if you get on Marketplace or eBay and you search slow speed grinder, you'll come up with some that are 1200 RPM or thereabouts. That's still way too fast for what we want. And these use a diamond grit plate. I'm basically loosely modeling this off of the Accu Finish, ACCU FINISH. So anyhow, the challenge for this is that I wanted to use parts that I had laying around the shop, which I got a lot of stuff laying around the shop. And just so happens that I have a DC motor, and so it has a direct drive, and it is rated, I think, and it also has a geared end, and the geared end I think has a max speed of 277 RPM. I saw that somewhere. Where did it go? Yeah, the fast tap 0 to 5,000, and then the slow speed 0 to 277. So it's actually adjustable. It's got a little rheostat there, and it does work. And I've had this kicking around the shop for there may be one less cat. Come here, cat. Anyhow, I've had this kicking around the shop for 7 or 8 years. I picked it up in a lot of stuff, and you know, I always thought, I'll find a use for it. I had a big piece of steel out here. I have no idea, mystery steel. It's in my junk pile, and then I have a handle for the top, and then I've got some aluminum bar stock that I picked up at a tractor show. Oh, I don't know, 4 or 5. It was before I moved down here, so I guess 5, 6 years ago. And I think I paid $2 a piece for these, and I think I bought like 10 of them. And then this, I'd ordered from McMaster-Carr for something, and never used it for its intended use. So that's the challenge. And I also have a piece 6-inch round of aluminum. It was a little over an inch thick, and I posted a short video yesterday. You know, I was just truing up one side of that and turning down the hub, and was just trying to, I wanted to be sure before I finished it out, and so I left it about 3/4 finished yesterday, and then I wasn't sure what my next step was. I was trying to not get myself boxed into a corner, but we'll go look at that here in a minute. So anyhow, stuff that I had laying around the shop, I've got a whole bunch of scrap sheet metal, and so I will mount this up. I've already measured. This has got 4 mounting holes, and so I think ideally what we're looking at, and I have to mount this silly thing up, and so looking at 6-inch diamond grit wheel. So I need, you know, 3 inches plus. It's just shy of 3 inches from the center line. That's actually a little over 3 inches. So by the time I put a set of feet on here, it'll be perfect. And then, you know, I've got, it's going to be a little offset, which, you know, might be, so we got, what is this, a little over 9 inches. Unfortunately, because of this, you know, I can't mount this in the center and have it wind up right. So I think probably what I'm going to do is I'm actually going to have the high-speed shaft come out the back side of it, anticipation for another project. And what that is right now, I don't really know, but I don't want to cut that high-speed shaft off. I mean, that would be kind of pointless. I do have the pulley that will fit it, and so here we are. So yeah, I've already measured out the bolt hole spacings, and they're set at 1 1/4 and 1 5/8, respectively. So that'll be easy to do, and what I'm thinking I'm going to do is I'll cut this to the same width as the steel plate, and we'll put a couple bolts through that to hold that in, and then this, you know, I'll probably just do some through holes from the back side of this, countersink the holes, and you know, and that way this will bolt to this, and then this will bolt to this, and it should be nice and firm. And then for the face, I'm probably just going to do sheet metal. Why not? So anyhow, just trying to feed this all together. This controller does have a forward and a reverse. Not that I think that's important, but it's just a feature that was already there. So let's go look at our actual backing plate. Alright folks, here we are back at the Cadillac lathe, and I picked this carbide insert tooling up some time ago, thinking, I can find a use for that. It's a round insert. I'm not sure actually what type of insert it takes, and I don't have any more, so I had to find some. But so I had this 6-inch piece of aluminum. Assuming it's 6061, it was pretty stringy. What I was trying to do was basically get down to a nub that I could hold, and that way I could machine the other side and the circumference of it. And then I just turned it in. I think it's just a little shy of 2 inches at the moment. And I was trying to decide if I wanted to take it down to size, which would be a 1/2 inch for the diamond lapping plate, and whether I wanted to go ahead and drill the through hole for the shaft. And I just couldn't make up my mind, because when I flip it around, you know, and I grab on this, it is aluminum and it has a tendency to mar, and so I think I'm probably just going to go ahead and flip it. I'll have to flip the jaws around on my 4-jaw again. I'll indicate it in, and you know, it is what it is. It's not a big deal. And then I'll drill the through hole, and then I'll flip it back around one more time, and I'll turn this hub down to what I want. But basically what I was finding is that this 6-inch piece was just odd size enough that it was a little bit difficult to get. You know, I could have gripped it in these, but I would have wound up with my chuck jaws hanging out a little bit, which, you know, it would have worked. It would have been fine. But you know, I get a little antsy about that. But the trade-off is that, you know, I was actually using this tool set out, you know, and it sits out, you know, 2.5 inches in front of my compound slide. So, you know, trade-offs. I probably could have just go ahead and gripped it here, and then use some kind of standoff. But you know, I wanted to seat it firmly so I could get that turn. More than one way to skin a cat. So I am going to just go ahead and leave this as is. I'll grip on this hub. I'll turn the OD of it. I'll face the other side, and then I'll go ahead and grip it back again on the OD, and then I'll turn down this hub to that. It'll be just shy of a 1/2 inch for the lapping plates. So that's where we're at, and so we'll start back up, and I'll finish doing the lathe work on this, and then I've got to order some magnets for that. So, you know, we got quite a bit more to do. We'll be back in a little bit. All right, so the first thing we got to do is we'll go ahead and pull this out of the 4-jaw, and I'll flip the jaws around. I don't actually have a chuck key for this particular jaw or chuck, so I got a 12mm socket on a 1/2 inch drive, and it works really well. And then so for jaw removal, I have another 12mm. But it takes all day otherwise. I didn't quite get it. Maybe I did. There we go. I just wipe her down. Shouldn't be much in there because I just flipped them yesterday. Come on. I got one jaw that wants to give me problems when I start it. There we go. And then we're going to go down somewhere around in there. All right, we're going to put you on time lapse. All right, for those of you who aren't familiar with the 4-jaw chuck, you know, I'm still fairly slow at this. You know, Adam Booth, you know, he is famous for centering a piece in a 4-jaw chuck. A lot of other guys do a really good job. You know, I'm not the greatest, you know, it takes me a little bit of time, but you know, it's not terrible. So the process is, on these chucks, they've got these series of grooves which are roughly an inch apart. They might actually be exactly an inch apart, I don't know. But it's a relative measurement, right? And so what I want to do is I want to get this close, and then I'll set up the dial indicator, and then we'll indicate it in. So, you know, I started with the front, and basically I looked at, you know, where was it at on the chuck, and then I got all of them close, and I still had some more room to go. And so then I got close to where it needed to be, and then I started looking at the back of the jaws, and you can see that the back of each of these jaws is lined up in this particular plate, right? And so that gives me a good place to start. I also want to make sure that I set that thing down, and it's just a rubber mount because I'm working on aluminum. And so this was one of the reasons that I I wanted to turn down that other side, is so I'd have a nice smooth flat surface to set. Yeah, it's not wanting to sit just exactly. Interesting. Alright, well, we'll sort that out here in a minute. Probably because I've got a little bit of a radius at the corner of that, and so what I'll probably wind up doing is just I'll free this out a little bit and it'll self-center. Alright, so next I'm going to set up my dial indicator, and this was kind of a pain in the butt to do yesterday because the jaws were in the way. It won't be so bad today. And you know, I'm just going to get it on here, and you know, basically all you're doing, and it's a rough extruded aluminum, right? So probably the best I'm going to get is, you know, 3 to 4 thousandths of run out. Plenty fine for what we're doing. This is slow speed, going to be 300 RPM. You know, it could be a lot further out than 3 or 4 thousandths. You'd never know it. So what I'm going to do then is you just measure jaws, right? And so I'm just going to take a quick look at this. All right, falling, 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 off the chart. All right, off the chart, and then coming back in. So I've got one side that is at least 30 thousandths high. So this jaw is at least 30 thousandths high. And so I'm just going to go over here to this other side, and I'm going to release some tension on that. We'll go back over to the high side, and then we'll squeeze that in, and then let's go ahead and go in a little bit further. All right, so now I'll go to this jaw. All right, falling, 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 and then we get to the opposite jaw. All right, and then we're climbing, climbing. So yeah, so let's do this. Let's I'm adjusting the cross slide, and they're not on the cross slide. Alright, technical issues here. Headspace and timing of the operator was off a little bit. Alright, so now we've got it set up so it's actually on my cross slide, so I can move this in. And alright, so let's start on that jaw. Alright, and as we go climbing, climbing. All right, folks, had a heck of a time getting a good finish on there with that tool. I'm pretty sure this is 6061, really stringy, nasty stuff anyhow. But you know, I had to play around with it, and you know, I just had a few spots that just, no matter what I tried, I couldn't get a nice perfect finish on it. I mean, to the feel, you can't, I mean, I can just barely feel the difference. But all right, and so the reason that I didn't bore this all the way to size, can you see this? So, you know, this is a critical dimension on it. It will be, and so if I'd have bored this down to, I'm going to do it probably at a 0.498, so it'll be a nice fit inside of a 1/2 inch hub. You know, you can see where those jaws gripped it, right? And so, yeah, I did the right thing. So now we're just going to flip it over. I think I'm going to leave the chuck jaws as they are, and I'll grip it around the extremity. And all I'm going to do is I'm going to turn this down to diameter, and then I'm going to drill it for the shaft on the little motor. So back in a minute. All right, so we're pretty close. Just a little. All right, folks, so yeah, this, you know, again, so the problem is that I wind up with reach issues, right? In order to get in here and machine this hub, I'm going to crash with the tooling that I have, with the exception of I can't actually use that bar again. I may wind up doing that. If I flip the jaws around, the 6 inches, I can't actually grip it on these set of jaws before the interior comes together. It just won't close far enough. So, you know, another option is I could actually loosen it up and slide a set of parallels in there, and then tighten it back in place, and then, you know, of course, Hey folks, all right, so we got the nubbin turned down to 1/2 inch. I was wanting to be about 0.498, and wound up being about 492. You know, overshot it by just a hair. It's going to be fine because I'm going to put drive pins in it as well as magnets. Just bothers me that I couldn't get any closer than that, but you know, it is what it is. So you probably noticed that I changed the setup because of the reach problem. What I did is I wound up using a set of parallels back behind it, and then got it dialed in within the forejaw. Then I went back to the face, lightly tapped the face until I got that set, and then went back and recentered the hub. So it was just the right thing to do. You know, I wanted to use a different tool other than that radius tool bit, and you know, and it worked out perfectly. You know, like I said, just sometimes you got to do what you got to do, and I just wasn't happy with how it was set up, and you know, it wasn't. I could have done it, but it would have been, you know, I'd have been doing some things that I don't really like doing. So now. The hole on here is 1/32, 0.312. It's a 0.312 shaft over there. I'm going to drill it with an M drill, which is 302, 303, something like that. Because typically, you know, it's going to drill a bit oversized, and I want this to be a snug fit. I'm obviously going to put I'll drill it and tap it for a set screw, but If I get it tight enough though, I may just go ahead and Loctite it on there, because that'd be a little better. But so anyhow, I've got a center drill lined up, and we'll bring us up here in just a moment, and center drill it with that Q drill, and then we'll test fit the shaft. And if it doesn't work, then I'll go ahead and put a 1/32 drill bit in there, and you know, it just is what it is. I don't have any super small boring bars, so I might actually have a 1/32 reamer. I'll have to see. If I do, I'll ream it. Hey, I'll be back in a minute. What are you doing? Let me catch this. Yeah, Daddy loves you. All right, we're taping. All right, it's on. All right, folks, so you probably noticed that my setup has changed. I just wasn't happy with it being recessed back in there. It caused a clearance issue with the tools I have, other than, you know, this one cutter that's got the round insert in it. So I basically used a set of parallels to space this out, so that I could get a grip on the jaws, but I could also still have some of this surface standing proud, so that I could turn that back down again as well. I've turned this hub down. Was shooting for 0.498, overshot that a bit. It's about 492. So yeah, I went. Actually, I had it good, and what I realized is that my cutter geometry was a little bit skewed, and so the backside of the cutter was cutting as well. So it was basically, it was tapered, and you know, by the time I corrected that, you know, I was 6 thousandths under. It's not going to make any difference, because I'm going to put locating lugs on this, and you know, there'll be magnets as well to hold the disc on there. So it is what it is. The shaft on our motor is 3/32. No, I'm sorry, 5/32, and about 312. It actually measures directly about 311. So I'm going to center drill this hub, and I'm going to drill it with a Q drill, which is supposedly 302. Normally they cut a little big, and what I want is a nice snug fit on there. I don't know that it'll cut that much over. Wouldn't surprise me if it did. If it does, great, we'll have a good fit. If it's still lacking, then I'll bring a 5/30. I actually think, yeah, I do have a 5/32 reamer there, and so we may wind up just reaming. Let's see. 302. Okay, so that was a 5/32, not a whatever the heck I don't know. I've been playing musical animals all day with cats popping in, and it's got me stressed. Yeah, so 5/32, no, 5/16, and ream that out, and it is a very nice fit with the shaft on the motor. And so that's it for lathe work on this. It's done. Yeah, so next we'll go on, and I'm probably going to cut the strip of aluminum to the length and then drill it for the mounting holes for the motor. And so that's probably what will be next. So we'll catch you here in a few. All right, so I went ahead and hit that rusty piece with a flap wheel and cleaned it up right nicely. And so I'm just going to cut this aluminum to the same dimension across there. And I don't know how square this thing is. I mean, it looks to be relatively square, but really it doesn't really matter. You know. So just hold it, mark it with a scriber, and then I will cut it off with the cold cut saw. And actually I'll probably just cut it off with the bandsaw, and then I'll put it up in the mill, and we'll mill it to size. So back in a minute.
All right.
All right, so here we are with the cold cut saw. This doesn't normally do all that great a job with aluminum, because especially 6061, no idea what grade of aluminum this is, but you know, the teeth tend to gum up with it, so just have to take it slow and yeah, this is the Evolution cold cut saw. Man, they are amazing. You know, if you cut that on a conventional saw, you wouldn't be able to pick it up and hold it. Works really, really good. I bought one of the early ones and wound up retrofitting an old Harbor Freight because when I bought this, it just had, there was no tilt mechanism, no swivel mechanism. And so I basically cobbled this off of an old Harbor Freight when it was on its last leg, and been using it ever since. Love it. But you can see, you know, it makes a pretty good cut. I've got just a little bit of bevel on there because that wasn't exactly set at 90, but close enough. So we'll just do a little deburring. Not even sure who actually makes this. Israel. I don't know. Several different companies make these. Noga makes some really nice ones. But you know, all it does is it just takes that burr right off the edge. And this has different ends for different materials, for plastics, for aluminum. And you want to use the appropriate end, because I have cut myself on using the wrong one of these. There's one of them that has a really sharp edge on it, and we'll just go ahead and do this whole thing. Can you come in real close? And you see it just rolls a little piece right off of the edge. And you know, literally you can deburr a piece and Hey folks, welcome back. All right, so yesterday I finished up lathe work on the backer plate, and order of operations is kind of important on this, and so I guess one easy way to deal with all this would be to draft it all up, and if it were a more complex part I probably would, but in all honesty it's just as easy for me just to set things out. So what we did is we marked this and cut it yesterday so that this is the same width as our base plate, and I narrowed down the width on our holes for mounting the motor, and so I've got a 1 1/4 inch from front to back spacing, center to center, and 1.675 spacing laterally across here. And so basically what I did is, I just crunched the numbers and figured, okay, where do I need to go to put my holes centered, front to back on, or not front to back, but yeah, front to back on this, and it wound up being 0.375. And so just use some red Dykem. For whatever reason, I can't find my blue Dykem after an hour of searching this morning. I'll probably find it this afternoon now. Laid it out. I center punched the one hole, and I'm going to use that one hole then to locate the other 4 holes. These will be through holes that go through, and then it'll be countersunk on the back side, and so that way I'll, these are, I don't even know what they are. They're some kind of fine threaded screw. I'll probably just reuse those because they are a fine threaded. That'd be difficult to find. So we'll set this up in the mill. We'll find our datum point, which is the one hole that I have center punched, and then we'll just step it off with a DRO, and we'll drill all those through holes, and then we'll flip it back over, and we'll go back to the mill again, but we'll just basically find the center on that. I'll stick the drill bit back in the chuck upside down so the shank is out, locate the hole, and then we'll counterbore each one of those down so that we can use those same screws. And so what that'll do is it'll allow us to mount this to the motor. What that was, precision square, that was nice. And all I did to even get the start on this is, I laid this up here and I looked at spacing front to back, and I've got quite a bit of leeway, and I just I picked a position that looked good for me, and I marked the edge of it, and then from there that gave us a datum point to start with. All right, we'll go to the mill next. Back in a few. All right, folks, here we are back on the mill. I got this set up, and I have my datum point over here, and basically I just moved the table around until I was able to zero, and I just got a little center drill there. I don't have a super small my brain's not functioning yet today. Anyhow, and what I went ahead and did is I laid this all out. I marked where I thought they should wind up, and then lo and behold, there were 2 of them that were out, right? And so I had flip-flopped my dimensions. So it's always a good idea. Lay it out, verify that that's what you want, set it up in the mill, and then do a dry run before you drill any holes in or anything like that to make sure that you're where you want to be. And so at this point, I've got everything lined up. We'll go back to 0, 0, and I've got a little keyless chuck in here, and so it makes it pretty easy to drill and then take it out and do the other drill. Doesn't really matter all that much. And so we're going to drill basically a... Alright folks, so I'm going to do a 3/8 inch counter bore. I don't have a 3/8 inch counter bore, so I've got a 3/8 inch 2-flute end mill. And basically what I've done is I've flipped the part over, I've reacquired this hole, which would be my datum hole, and then everything else should just step off by the DRO. If it's off by 1,000 or 2, it'll make zero difference. So I'll start it up, I'll feed this up until I just start cleaning. Alright folks, so we're off the mill. Yeah, we've got not quite a 1/4 inch sticking out there to engage into the motor itself. And I'll wind up doing probably just a blue Loctite, maybe a red Loctite. I guess the key thing is do my do my bolt holes match up? That's the question. That's always the question. Did you do it right? It looks like it's going to work. That's 2. That's 3. It's always nice when you get it right. Alright, so that amount on there just like so. And then, so because of, order of operations, this is going to be more or less permanently attached to our aluminum plate. I'm not going to have access to put a bolt here. So what I'll wind up doing is I'll put probably 2 1/4 20 cap screws there to hold this down to this plate, and that'll be fine. And I've got to look at where exactly do I want this. I'd like this to be more or less in the center, but with that being said, I don't want this stuff hanging out of the back of it. And so set up something as an edge. Yeah, that's about where it's going to be. And I will have this shaft sticking through. May not ever actually use it for anything, but I might. So I don't know. We'll see. If I cut the thing off, then I'll think of something really cool to do with it later. And then so if we go here, I got just a little over 2 1/4, and we go this way about 2 1/4. So yeah, that's going to work out just fine. I think I'm happy with that. Fact is, I'll go ahead and I won't mark it because my scry is sitting over on the mill, but I'll go ahead and mark that. And then we'll go ahead and drill the 2 clearance holes for 1/4 20. I'll counterbore those as well. And actually, you'll see if I have 2 1/4 20 cap screws laying around somewhere. And then we'll attach this to that. And yeah, we're getting close there. We're getting real close. All right, so back in a minute. Alright, so got this set up in the mill. Like I said, I've just got an arbitrary mark here. And all I did was I looked at, where can I reach over and put 2 screws down without interfering with the motor mount and the way it's mounted. So this is 2 inches wide, and so what I'm going to do is I'm going to go 1/2 inch in, drill 1, and then 1 inch and drill the second one. So I've got an edge finder in here, and all this thing does is it just flops around. It's got a 200 thousandths diameter end, and so you start it up and it'll and then as you get closer, it'll come into contact, and then as soon as it starts to, well, there you are, right? And you can do that a couple times just to make sure that you're really there. This is not super percent, you know, this is just, I'd like it to look like, you know, I spent a few moments to do it right. So anyhow, we'll find the edge. I'll move in. So as soon as I get this where it's running even, and then it starts to shoot out, I'll go ahead and zero my y-axis. I'll move it over 100 thousandths. I'll re-zero it, and then I'm going to move my ½ in, and then that will be my datum point for that hole. I'll zero it again, and then I'll move 1 inch down for the next one. All right, so here we go. All right, and see it's just flopping around, and then as we come up on this, you see that the run out gets less and less and less and less. And then, whoop. Must be a little aluminum chip in there. All right. We'll go ahead and zero that. And that's all I need for that. All right. So go ahead and pull this back up, get it out of the way. And then all right, for a counterbore, just, you know, going with the drill. All I'm really trying to do is deburr this a little bit. All this shit's going to be hidden. It just barely works on that one. And so that was a whole lot faster than going back over and hitting all the spots with the DRO. So there we go, deburred and countersunk. All right, folks, and we're back. All right, so as I talked about, you know, we're going to set this up here on our line. We're going to make sure that our edges are lined up, and then we're going to use a thing called a transfer punch. All right, if you don't know what a transfer punch is, Harbor Freight sells them. They're relatively cheap. I don't know, I think these are 20 bucks, something like that. They're not very expensive. And what they are is they are incrementally sized. And so the idea is that punch will just barely have clearance to slide through there, and then it's got a little dimple in the center of it. And so that gets you really, really close when you're transferring hole locations from one piece to another. All right, so I've got that set up there. And I'll set that in there, double check everything one last time, hold it down firmly, alright, so that one's transferred. Let's Still holding. Move over here. That one's transferred. So now I got my 2 holes there. All right, and I know those are an inch apart. So we're probably just going to go ahead and go back to the mill, and I'll drill these on the mill. And so then what are we going to drill? Well, it's a 5/16 18, and so there's a thing called a tap drill. All right, what is a tap drill? A tap drill is, so basically if you look at a tap drill versus your bolt, it basically is allowing just enough room for the bulk of the bolt to pass through, but it allows room for you to then to cut threads with your tap. All right, so tap drill, in this particular, and there's a tap drill chart. Pick you up yourself a machinery handbook. You know, you can buy them used for 30, 40 bucks, sometimes as low as 20. I've bought them as low as 10 every now and then. Buy one. It doesn't matter how old it is, just buy it. It'll have your tap drill sizes and a whole lot of information that you never even knew that you didn't know. All right, so those are in there. I'll drill it. The tap drill size for this is an F. And so you're probably wondering, well, what the heck is an F drill? All right, so generally speaking, drills, especially when we're talking about Imperial SAE, so everybody I'm sure is probably familiar with, you know, the fractionals, you know, 3/8, 5/16, ½ inch. All right, okay, so that's the most commonly used. Then we have the the letter drills, which are A through Z. All right, and those fall in between those fractionals, right? So these are arranged to fall in between those. And then we also have number drills, and there are actually 2 different number drills. What is it? 1 through 60, and then 61 through 80, or something like that. And so those are fairly small. You know, your number drills get down in the very small size diameter holes. All right. So we'll go, like I said, we'll go set this up. I'm going to locate one of these, and then I'll move an inch over to the other one, and we will be on. Now, how much, you know, I only need to actually tap about halfway. All right. But what I'm going to go ahead and do is I'm going to go ahead and drill all the way through, and that'll make my tapping a little easier. You know, wouldn't necessarily have to. I could drill a little beyond halfway, but you know, I have to leave extra room for the tap, because if you look at the tap, can you zoom in there? And there are different types of taps as well. All right, so this is, you know, a normal tap, and you'll notice that it's tapered here at the front, and then it gets to full size, you know, probably, I don't know, maybe 3/8 of an inch up the tap. Well, if I have to have engagement all the way through, well, if we look at that, I mean, I almost have to be all the way through with the tap to get full engagement for this particular cap screw. So I'm just going to go ahead and drill all the way through this. I'm going to make it a through hole, and then I'm going to tap this probably to the top of the threads. And I'm just going to hand tap it. But yeah, so let's go set this up in the mill. Let's drill those F drills, and then we will go ahead and tap it. And I might chuck the tap up and start it. I don't know what kind of steel this is. So I don't know, this might be interesting. All right, to the mill. All right, folks, here we are. Set back up in the mill. I got a set of thin parallels here. Not that I need thin ones, but I went ahead and centered up on that hole, and then let's go ahead and move over an inch. And how about that? Puts us right on that hole. All right, so that's what we're looking for. I do have a long center drill in here. Again, I don't have a spotting drill small. Alright, we're going to try to power tap this. I don't imagine it'll go. I've got it lubed up there and got my speed dropped down. I'm in low gear. And alright folks, so got the screws set in here, and I'm going to go ahead and thread lock these screws holding it to the motor. I don't see any reason to take this back apart. And this is medium strength, so if I do have to disassemble it, you know, it's not the end of the world. It's not going to be impossible. Alright, and then the easiest thing to do here would be set those in there like so, and then let's get one started. And one, there's two. Three, and there's four. Alright, so we got all those in there, and I'm not over torquing them, but I do want them to stay. So, alright, so that is locked in there, and then we can go ahead and drop these guys in here, and I'm not going to thread lock. I will thread lock these at the end, but for now, you know, if you want to take this back and forth apart, and let me pause here for a second and go get a Allen key. All right. And I did run a countersink on the back side of the holes on this bigger plate. Right. And there is a little bit of adjustment there if we wanted it. It doesn't look like we need it. It's a little bit twisted. There we go. There is just a little bit of adjustment there. So there we go. We've got the bare bones of this done. Let's fire it up. I am going to put a new cord on this, or at least a new end, because this thing scares the hell out of me every time I plug it up. Alright. And let's go ahead and put the cord. And so I still had to put a table and figure out how I'm going to mount that table there. But yeah, I think that's going to be just fine. Alright, please like and subscribe, and we'll start working on the body on our next episode.